Hi everyone, this is TSR. Today we are here to discuss about irrational numbers and their properties in exercise 1.4. This exercise is very important for us regarding long answer questions 6 marks and short answer questions 4 marks. So most of the question papers are containing these questions in numerical changes model. Okay na? So focus on this one, listen to me very carefully, very clearly I will explain in detail, right Nana. So what it contains? It contains irrational numbers. Already I told you rational numbers are represented with q. They are of the form p by q, where p comma q are integers, coprimes, q not equal to 0, like that. Okay na? Its related discussion we completed in exercise 1.1, 1.2, 1.3. In this we are discussing about irrational numbers which are not rationals, represented with q dash. So which cannot be written in the form of p by q are called irrational numbers. But what is their general representation form? Irrational numbers can represented with a form, that one is nth root of a, where n is called order of the third model inserts, where here coming to here n will become, n is a natural number and n is greater than or equal to 2. Coming to this exercise concept, a is a rational number which is positive. A is a positive rational number, but a cannot be written as nth power of any other rational. Is that clear, Nana? A is a positive integer. Inside radicand is positive integer, but a cannot be written as nth power of any other rational number. Is that clear, Nana? So that type of general representation can be taken for irrational numbers. Is that clear, Nana? So along with this representation we have two more symbols, those are called pi value, which is equivalent to 22/7, and logarithmic base e. Pi comma e are also considered as irrational numbers, but these are called transcendental numbers. Is that clear, Anna? Remember this one. This concept is given in the earlier classes. So in bits they will ask you regarding pi e. These two are also irrational numbers, but they are not in the form of nth root of a, because rational numbers are in the form of terminating decimals or non-terminating repeating decimals. Are rational numbers. So irrational numbers in the decimal form, they will be of the form non-terminating, non-recurring, means non-repeating. Decimal form of irrational numbers are non-terminating, non-recurring, means they will not end, decimals not ends, and numbers, digits in the decimal part will not in repetition. That's why non-terminating, non-repeating. Is that clear, Nana? So pi comma e are also come to in that non-terminating, non-repeating category model. So they can be treated as irrational numbers. Remember that these are called transcendental numbers. Okay, na? So this is the briefing regarding irrational numbers. Very good. So what is the bit part type questions they can ask? Means the sum or the difference or the multiplication or the division of a rational number and an irrational number is always irrational. Remember that one. In bits they will ask you. Sum or difference or multiplication or division of a rational number and an irrational number results always irrational number. Simple example, 2 plus root 3, 2 minus root 3, 2 into root 3, root 3 by 2. These all are belongings to Q dash, irrational numbers. Whereas sum or difference or multiplication or division of two irrationals may be rational or irrational. Two irrational sum may be rational or irrational, difference may be rational or irrational, product may be rational or irrational, division also may be rational or irrational. There are some separate examples for them. Okay na? In bits, theoretical bits only they will ask you by giving options like that. Okay na? Simple example I will give you na. Root 5 is rational, minus root 5 is also irrational. If you add them, answer will become 0, which is rational. Whereas root 3 irrational, root 2 is also irrational. If you add them, it remains like that only and it will become irrational. So, sum of two irrationals may be rational or may be irrational. Is that clear, Nana? Like that for difference, for multiplication, for division also we can take the examples. Okay. So, little information only I am giving, but it is very clear. What long answer questions or what short answer questions are there according to our syllabus, that one we will discuss now. So, that complete problems, that type of complete problems are there in exercise 1.4. So, now today we are here to discuss about the most important problems from exercise 1.4, which are very important for 6 marks and 4 marks, right. The most important questions from this one is from first bit, second one, third one, fifth one. These are very important. So, what is the speciality of these questions? So, first question is given like this: prove that the following numbers are irrationals. Prove that the following numbers are irrationals. In that, second question contains number, given number as root 3 plus root 2, root 3 plus root 5, sorry. So, they are asking to prove that root 3 plus root 5 is irrational. Okay na? So, how do we do this problem? In the contradictory method we will solve this one. Very important for 6 marks, Nana. Listen to me carefully. So, in the contradictory method we will do. So, what that process? Let us suppose, let root 3 plus root 5 be a rational number. Therefore, root 3 plus root 5 can be taken as a by b because it is rational, where a comma b belongs to z, comma ordered pair of a comma b is equal to 1, means both are co-primes, and b not equal to 0. This step is compulsory. Just for writing this step you will be awarded 1 mark. So, this one contradictorily we have taken as irrational, so that it can be written as a by b with this property. Since it is a by b, right side one is rational, left side two terms are there, root 3 first term, root 5 second term. Both are irrational numbers, that one we know. Okay, and clearly their sum. Since these two are irrationals, just to do squaring on both sides. If there is any rational part, we have a chance to send that rational part to rational side. If both the terms are irrationals, I think it is not necessary to send irrational term to the rational side. Irrelevant will become. okay na? But in textbook that model only there, it look like a little bit confusion. So if both the terms are irrationals, do squaring on both sides, then root 3 plus root 5 whole square is equal to a by b whole square. Am I clear, Nana? This implies using a plus b whole square formula, a square will become 3 plus root 5 whole square will become 5 plus 2 into ab will become root 3 into root 5, that will become root 15 is equal to right side one will become a square by b square. By applying a plus b whole square formula, a square plus b square plus 2ab value is this one, right side a square plus b square. This implies this is 8 plus 2 into root 15 is equal to a square by b square. Am I clear, Anna? Now if you observe that square of rational is also rational at the right side. By simplifying the left side part, we got 8 plus 2 into root 15. Okay, if you observe this LHS part, this is rational number, this is also rational number, this is irrational. So what we are trying to do is try to send the rational terms to the rational side, right side, by step process. What we will do, 8 plus 2 into root 15 means this is the first term, this is second term. Remainder second term as it is, send the first term to other side. Remember this one. 8 means its sign actually plus 8. Send that plus 8 to the right side, automatically it will subtract the other side one. So it is equal to minus 8 to right side value, a square by b square. Am I clear? What is remaining here? 2 into root 15 is remaining here. If it is positive value will remain. If there is minus symbol, minus will remain. Keep it in mind. This implies 8 is going to the other side, remaining part remains as it is, equal to a square minus b square minus 8. Just simplify this one without any confusion. Just simplify this. This implies 2 into root 15 is equal to a square by b square minus 8 means you can do little simplification. Take b square LCM, then this is a square minus 8 times b square. Clear? That's it. Now 2 is again irrational. Right side one is this total part is always irrational because a by b is irrational. Sorry. Right side one is always rational because a by b is rational. Right. This implies root 15 is equal to into 2 is coming to the right side, so it will comes in the denominator form to the already existed value a square minus 8b square by b square. Got it, Nana? Multiplying value will go to the other side to divide, just it will divide the right side value. Therefore left side one is irrational and right side one is clearly rational. That one we got. Irrational equal to rational we got. Is it true? What I told you already, which is not rational is irrational, but here we are getting irrational is rational. This is mathematically wrong. That's why we can write it as which is absurd. Absurd means mathematically wrong. Why we got this absurd? Because of our consideration, root 3 plus root 5 as a rational. So that supposition is wrong. Therefore root 3 plus root 5 is not rational. If it is not rational, automatically what it will become? Therefore root 3 plus root 5 is an irrational. Is that clear, Anna? That's it. Very limited steps, but very important for 6 marks. Is that clear, Nana? But in the examination, direct questions will never come. Their applications will come. So I will try to write some extra problems here because it is very important. You can take root 7 minus root 5 as the first example. Prove that this one is irrational. Second one, 2 root 3 plus 3 root 2 as an irrational by using this process. Third one, 3 root 5 minus root 2 as irrational from this part. Is that clear, Nana? Have you understood this one? Right. Then we will go for third question. Now observe this third problem. First bit, third problem. What they are saying? Prove that 6 plus root 2 is an irrational. This one. What we have to do? Solution. I told you na, contradictory method. Let 6 plus root 2 be a rational number. Rational number. Therefore, 6 plus root 2 can be written as a by b, where a comma b belongs to p by q rationals. Sorry. A comma b belongs to z, ordered pair a comma b is equal to 1 and b not equal to 0. Is that clear, Nana? That is the property. Now, if you observe this, right side one is rational clearly. That is our consideration. Left side 6 plus root 2 is there. Clearly 6 is rational, this root 2 is rational. So, we have a chance to send rational fellow to the rational side, like terms model. So, this implies root 2 is equal to a by b. When it comes to this side, subtract the other side fellow, minus 6. This implies root 2 is equal to b is LCM, then this is a minus 6b after taking LCM. Therefore, it gives us irrational is equal to rational. Correct? This total is rational part from the rational. Okay. Irrational is already I told you, which is absurd, mathematically wrong. Therefore, 6 plus root 2 is not rational. Our consideration is wrong. Therefore, that's why 6 plus root 2 is an irrational. Clear, Anana? That's it. This model questions many they will ask you. In the same way, come to the last one, fifth problem. So, in fifth problem, the given number is 3 plus 2 root 5. 3 plus 2 root 5. We need to prove this one as an irrational. So, this is the given number. So, let 3 plus 2 root 5 be a rational. Rational number. Therefore, 3 plus 2 root 5 can be written as a by b or p by q, where a comma b belongs to z, ordered pair a comma b is equal to 1 coprimes and b not equal to 0. This implies, observe that right side one is rational is our consideration. Left side 3 plus 2 into root 5 is there. 2 as rational, root 5 irrational. Send the rational numbers to the rational side step by step. Then plus 2 root 5 will remain here is equal to, when plus 3 is moving to other side, it will become minus 3 to the existing value a by b. Just to simplify it, this is 2 into root 5 is equal to b is LCM, this will become a minus 3b. If you send into 2 to other side, it will comes in the denominator to divide the other side fellow, a minus 3b by b. It will come in the denominator. So, who is remaining here? Root 5. If 2 goes to the other side, root 5 is remaining. This is the right side term what we can write. This one is 3, Nana. Therefore, here also we got this is irrational is equal to rational, which is absurd, mathematically wrong. Therefore, 6 plus 2 into root 5, 3 plus 2 into root 5 is not rational. Therefore, 3 plus 2 into root 5 be an irrational. That's it. That is the problem. These type of questions they can ask for 2 marks or for 4 marks. Their application types. Okay, Nana? Right. Pass. Okay, Nana? This model, some extra problems also we will take. Extra problems of this model. So, in the first 3 model, we can take the numbers as 3 plus 5 root 2, 4 minus 3 root 2. Negative values also you have to habituate. Third one, root 6 plus 2. Okay. And in this fifth model, you can take 3 plus 2 into root, 5 plus 2 into root 3. Fifth one, 3 plus 5 into root 2. Sixth one, 2 minus 3 root 5 with negative values also. Like that you can take enough number of questions you can take. Seventh one, generally root 3 minus 2 into root 5, like that. You can take many more. Solve them in the same process. You will get much better application skills process. Thank you.